We've used kinematics to describe motion and dynamics to explain its causes. In this unit, we'll talk about the limiting factors for motion in the form of energy. The most basic scientific definition for energy is that it's the ability to do work. But I have my own personal definition that I prefer to use. I think of energy as the ability to cause pain. This gives you an easy qualitative way to assess how much energy an object has. The more pain it causes, the more energy it has. So what are some ways to cause pain? I can throw something at you, and when it hits you, it can hurt, right? Because it has kinetic energy, which is energy due to its motion. If you lay on the ground and hold a rock over your head, that rock has the potential to cause pain, which gives it potential energy. Thermal energy can be used to burn, and so can solar energy. Chemicals can cause pain, and so can electrocution. And maybe the biggest of them all, I can use nuclear weapons to cause a whole lot of pain. One thing that's the same about all these forms of energy is that they're scalar quantities, which means that we're not concerned with their direction. We're going to need to define some basic terms in order to study energy. First thing is the system. We'll decide what goes in our system. Anything else is part of what we call the environment. The total energy of the system is the sum of all the energy that's inside the system. In general, our system will consist of three things: some object, the Earth, and any springs or spring-like materials that may be present. Our total energy, then, is made up of the kinetic and thermal energy of the object and any potential energies due to the Earth and or any springs. So what happens with the energies inside a system? Kinetic energy can become potential energy, and potential energy can become kinetic energy. Both kinetic and potential energy can be converted into thermal energy, but that's a one-way street. These are examples of energy transformations. Energy transformations are changes of energy within a system from one form to another. Let's look at an example. The first thing we need to do is to define our system, and our system is going to consist of the skater and of the Earth. The skater at the top of the ramp has potential energy due to their position above the ground, and the system has a certain total energy, which is the sum of their kinetic, potential, and thermal energies. So what happens when the skater rolls down the ramp? As they go down the ramp, their potential energy transforms into kinetic energy at the bottom of the ramp. And as they go back up the other side, that kinetic energy transforms back into potential energy. Notice, as the kinetic and potential energies transform between each other, the total energy remains constant. If you introduce friction to the system, we'll see how kinetic and potential energy can transform into thermal energy. And since that's a one-way street, over time, the total of the kinetic and the potentials is going to decrease as the thermal energy increases. But the total energy of the system is going to remain constant. All these transformations are happening within the system. So what about the environment? Work can be done to add or remove energy from the system. This is called an energy transfer. Energy transfer is the exchange of energy between the system and the environment. So again, our system consists of the skater and of the Earth. And you notice that right now the skater and the Earth have zero total energy. So how do we add energy into the system? An outside force can transfer energy into the system. That outside force in this case is me. Skater goes from zero energy, I lift them up, and now they have a certain amount of energy. I can also remove energy from the system by taking the skater and putting them back down on the ground. Though usually it's friction that removes energy from the system. So how does energy transfer affect the system? So the total energy of a system changes by the amount of energy that's transferred in or out of it. If positive work is done by an external force, it's going to add energy to the system. Negative work is going to remove it. If the system is isolated and there's no external work done, the total energy remains constant, so the change in energy is zero. So there's no transfer of energy between the system and the environment. So let's see if we can use our new knowledge of energy basics to answer this question. A child slides down a playground slide at constant speed. The energy transformation is, and they give us 5 choices. First thing to recognize is we're talking about an energy transformation. So we're dealing with changes in energy inside of the system. We can have potential into kinetic, kinetic into potential, or either one of those into thermal energy. The next thing to recognize is that the child is moving at a constant speed. The fact that it's a constant speed tells us 2 things. One is that kinetic energy isn't increasing, so potential energy isn't going into kinetic energy. And 2, kinetic energy isn't decreasing, so it's not going to potential or into thermal. So the only thing we're left with is gravitational potential energy transforming into thermal energy.